Hello, pre-calculus students. Today we're going to solve problems in both exponential and logarithm form. On the screen right now are the problems we're going to solve in this video. So here we are with our first problem. Clearly, we're going to do the exponent first, then the multiplication if we were doing the order of operations. So we need to undo those in reverse order, as we always do when solving algebra problems. So the first thing we'll do is divide both sides by 2. Now I'm going to solve this problem two different ways. X is the exponent of 5 that gives me 16. Let's go through that again. Listen to the words. X is the exponent of 5 that gives me 16. That's pretty handy. My handy dandy calculator won't do log base 5. It will do log base 10 and log base E, common log and natural log. Now, I always have a hard time writing the word log. It's the O and the G. It just always looks ugly. To be honest, ln is easier to write. So I'm going to use the change of base formula using the natural log. I'm going to take the ln of this divided by the ln of this. And when you use your calculator, round it correctly to 3 decimal places to get this number. This is an exact answer. This is a decimal approximation. If you want to give me some points back on your test and quiz, when I ask you for an exact answer, just give me a really long decimal number. Yeah, you'll be giving me points back. You can do this all day long. That's not exact. It's a decimal approximation. This is an exact answer. I'm going to solve this another way. I'm going to take the natural log of both sides. And I know that from our last lesson, I can move that x out front. Now this confuses people. I don't know what this number is off the top of my head. Some decimal number. I don't even know if it's greater than 2 or less than 2. No, it's got to be less than 2. But I know it's a constant. If I hit ln of 5 on the calculator, there's only one number it can be. It's a constant. So just as if this were 5x, I'd divide both sides by 5. If it's the ln of 5 times x, I'm going to divide both sides by the ln of 5. Now again, this is the exact answer. This is a decimal approximation. So we had a variable as an exponent. That's a logarithm. We take the logarithm, or we use logarithms to solve that problem. Alrighty, here's our next problem. Clearly I need to add 7 to both sides. Now, how do we undo an exponential with base e? Answer that to yourself. What is the inverse function of an exponential with base e? Well, it would be the logarithm base e, or the natural log. So I'm going to take the natural log of both sides. Now, natural log is just log base e. So the exponent of e that gives me e to the x is just x. In other words, these two functions are inverses. They undid each other. So the answer is the ln of 30, which is approximately 3.401. Again, I want to point out that this number is exact. That's like square root of 7 is an exact answer. You know, whatever that is as a decimal is its decimal approximation. Same here, the ln of 30 is an exact answer. 3.401 is only an approximation. Here's our next problem. Are problems like this ever encountered in the real world? I doubt it, but they're fun algebra problems, and this really is just algebra. You might notice this looks familiar to you in that it's kind of sort of like a polynomial, only with e's instead of just x's. So if we substitute m for e to the x, I use m for Miller. It's a Miller variable. Well, e to the 2x is e to the x to the second power, because then, you know, power raised to a power, you multiply the exponents. So that's e to the x quantity squared. Minus 7 e to the x is just m, plus 12 is 0. Well, that's a simple polynomial that we can factor now. And we can use the zero product property that says when you have two numbers being multiplied to give you 0, one or both of those numbers has to be 0. So either m minus 3 equals 0 or m minus 4 equals 0. That makes these pretty easy to solve. M equals 3 or m equals 4. Well, the problem doesn't have any m's in it. It's got x's. So now we need to go back and do our substitution again. If m equals 3 and m equals e to the x, then e to the x equals 3 or e to the x equals 4. Again, answer to yourself, how do we get this x out of the exponent? I'll give you a hint. X is the exponent of e that gives you 3. So x is the ln of 3. You take the natural log of both sides. On this side, you'd be left with x. Here, you get natural log of 3. Same thing here. Take the natural log of both sides. You get the natural log of 4. Now, in the interest of time, I have not been substituting my answers back into the original equation to check them. However, you know that you should, because why go through all this work only to get a wrong answer? I happen to know mine are right. But why would you go through all this work and you just made a boo-booski somewhere? Take your answer, substitute it back into the original equation. Alrighty, here's our next problem. I want to note something. When we're dealing with logarithms, we have some domain issues to worry about. For instance, what is the, just go back and do a little review. Answer this question to yourself. What is the domain of the log function, any log function? Think of its graph. What is its domain? Well, it turns out that the domain is x is greater than 0. So 4x has to be greater than 0, x is greater than 0. And here, x has to be greater than -12. So that tells me, you know, where do these two overlap? Because both have to be true. The domain, whatever answer we get, x has to be greater than 0. Because if you get a number, let's say -5, well, -5 won't even work here because we're not able to take the log of -20. It actually can be done, but you get into imaginary numbers, and we don't want that. Why do I always have such a hard time with that O? So what I've done in this step is I said we're subtracting two logarithms. I must be dividing these two numbers. So my next question, what base are we dealing with here in this problem? And the answer is we're dealing with base 10, because whenever we write log, it's base 10. If we write ln, it's base e. Now, I have seen some college textbooks, when they refer to log, they actually mean natural log. Some of these books like pretend common log doesn't exist. For our, that's some books, not all. So for our purposes, log is base 10, ln is base e. So this is base 10. So what is the inverse operation of log base 10? Answer to yourself. What is the inverse operation of a logarithm? It's an exponential. So let's raise 10 to both of these. And now the exponential with base 10 and the log base 10 undo each other. And what we're left with is just this argument. Here, the exponent of 10 undoes the log base 10, and we're left with the argument. It's easier to see over here. If you read this the way I taught you, this is the exponent of 10 that gives me 2. I don't know what that number is, but it's a constant. You know, it's 10 to what number gives you 2. That's what this is. Well, I don't know what it is, but if I make that an exponent of 10, we just said that 10 to this number would give me 2. So that answer must be 2. Again, the exponential with base 10 and the log base 10 undid each other, and I'm just left with the 2. Multiply both sides by x plus 12. These cancel. I'm left with 4x equals 2x plus 24. 2x equals 24. X equals 12. Now, is that number greater than 0? Yes, it is. So that's good. Then what I would do is I would substitute 12 back in here. Log of 48 minus the log of 24. That's the same as the log of 48 over 24. Well, 48 over 24 is 2. So that is the log of 2. So it does check. Here's our second to last problem. Again, we're dealing with logarithms, so we have to worry about domains. Here, I know that x has to be greater than 0. Here, I know that x has to be greater than -1. So, x has to be greater than 0 for my answer. Again, I'm subtracting the logarithm, so let's write it as one single logarithm. I must be dividing the numbers. How do I undo a logarithm or a natural log? What is the inverse operation of the natural log? Answer to yourself. Well, this is log base e. It's the exponent of e that gives me this. So I'm going to make it an exponent of e, and that will give me this. I don't know what e squared is, but I know it's just a constant. Let's multiply both sides by x plus 1. Then I get x equals e squared x plus e squared. Do not be intimidated by this. E squared is just a number, like maybe like 7 or something, 8. Don't worry, that's just some coefficient of x. If it were 2x, you wouldn't worry. So if it's e squared x, don't worry, it's just a constant, which we're now going to bring to the other side. Because now we're going to factor the x's out. And solve. What's the answer to this problem? What value of x satisfies that equation? None. X has to be greater than 0. Where did this come from? Well, it's an artifact of some of the math that we did. We got rid of the logarithm and came up with just this rational function, which is x can't equal -1 is the only problem here. We got rid of the fact that x had to be greater than 0. In other words, x cannot be negative. We got rid of it when we raised e to those powers. So in this case, it's very important whenever you're dealing with a log function, you have to note your domain. And our answer here had to be greater than 0. It wasn't. Substitute that in, and you get a yucky stinky. This problem, our last one, these are my favorite types. You have two different bases. Like, ooh, that's no fun. Yes, it is. So I'm going to take the log of both sides. Now, as I said before, I usually like to do the ln because it's just easier to write. I'm actually going to do the log, the common log, base 10, because I want you to see that we can solve these problems using any type of log we want. And once we take the log of both sides, I can bring these exponents out. And you notice that by taking the log, my variable's no longer in an exponent. And again, I don't know what the log base 10 of 2 is, I know it's just a constant. And same with the log base 10 of 5. Common mistake. People write x minus 1 without parentheses. I know what you mean, but it's not mathematically correct. X minus 1 with no parentheses followed by a log 5 means x minus 1 log 5. The x never gets multiplied by the log 5 unless you put the parentheses there. Am I picky about that? Oui. There, I used a little French. Now I'm going to distribute the log 5. Again, I don't know what it is, but I know it's a constant. And if I made this log 5x, is it log of 5x or is it the log of 5 times x? In this case, it's one of those times where it's easier to put the logarithm or the variable in front of the constant. Kind of like you would if it was square root of 2 times x. Well, is the x under the radical? Is it the square root of 2x? Or is it the square root of 2 times x? Sometimes we just write x root 2. You put the variable in front so that it's not confusing. Same here. Now what I'm going to do is I'm going to take, I need all the x terms on one side so I can factor them out and solve for x. So I need to bring that to the other side. Factor the x's out. Divide. Now, I could have all these negatives, but you'll notice if I factor a -1 out of this, it can cancel with this one. So I'm going to rewrite this as the log of 5 divided by log of 5 minus log of 2. Down on my number of negative signs. So again, if I want to think I skipped a step, it's negative log of 5 divided by this. I factored a -1 out of this. Then that -1 canceled with this -1. I'm left with this quantity, which when I put it into the double box, gives me that answer. Let's actually check our work. I'm going to substitute 1.756 up here and see what I get. Is that equal to 5 to the... So if I punch this into the calculator, I get 3.378, correctly rounded to 3 decimal places. And this I get 3.376. Oh, not quite right, but it's okay. This is a decimal approximation. It's bound to introduce a little error. If I substituted this up here, I would in fact get the correct answer. So, hope you've enjoyed doing those algebra problems. I always find these types of algebra problems with logarithms to be fun. They're not difficult if you know what you're looking for, if you consider that the logarithm is an exponent. That's the most important thing that you can get out of it. That and knowing that if you have a variable in the exponent, that makes it an exponential function. The way to get that out of there, the way to do the inverse of that exponential is with a logarithm. And if you're taking the logarithm of a number, the inverse of that is the exponential function. So that's all I have for now. Have a great day.